Okay, so this is a Bernoulli equation. Okay, it's not separable. Try as you might, you're not going to be able to separate the y cubed and the t into a function of y times a function of t. Okay? Not linear. Because of the y cubed, right? But if it wasn't for that y cubed, it would be linear. Okay? So we have the idea that we can do a change of variable. Okay? Let v equal y to the m. Okay? Okay, you're going to find out that m equals 1 minus n, where n is the power of y that makes it not linear. We'll make it linear. Okay? Well, let's work that out. So, let v equal y to the negative 2. Okay? Okay. Well, what do you have to do to express this in terms of v? Well, we did it
Find v
in
prime.
symbols. Yeah. What's the expression for v prime? And what's the expression for y in terms of v? Right? So, you know, give you this much. This should be obvious, but it isn't always. Y equals what?
Square root of.
Okay, well, let's see. You got v.
Square root of y.
V equals 1 over y squared, right? So y squared v equals 1, right? So that'd be 1 over the square root of v, right? Or if you just do it with the exponents to make sure we're right, because it's always a good idea to check these things out fairly thoroughly, right? Just dealing with exponents, what exponent do you need to make this side equal to y? The negative reciprocal, the reciprocal, okay? Exponent, and then multiply the exponents, you get 1, so you know you have y. You know, on the other side, you're going to get v to the negative 1/2. That's algebra 1, okay? But if you haven't done it in a while, it doesn't hurt to remind you, okay? Okay, So, just using very fundamental algebra.
What do you think?
I'll say b to the negative 1/2 and use 1/0 square root of v if you like. Okay? So, what do we do?
Substitute. Well, we still need to find what y prime is, and we substitute them in.
Okay. Yeah, so we have something to substitute for y here, both here and here, right? Okay, so what's y prime then? Because we've got to substitute for y prime. Well, it's a derivative of b to the negative 1/2, right? Which is negative 1/2 b to the negative 3/2. Easy enough. Okay? So the equation becomes, oh, forgot b prime there. Okay? It's a chain rule. Y is a function of v, so the derivative of y with respect to t is a derivative of v to the negative 1/2 with respect to t. V is a function of t, right? So you have a negative 1/2 power of a function of t, so you have a chain rule, and that should be very obvious. Okay, so the equation becomes, yeah, I started to write down the equation. I neglected to do this, and I was going to get an equation with no derivative. Okay? Which kind of tipped me off, and probably would tip you off if you did the same thing. Okay, so we have negative 1/2 v to the negative 3/2 v prime plus 3v equals y cubed. Oh, wait a minute. It's 3y. And 3y is going to be 3 times v to the negative 1/2, right? Because what's going to happen is this term is just going to become v, which is better if it's going to be linear. When I looked at that, I said, that's not going to become v. When I multiply this by v to the 3/2, I ain't going to get v. But now I am, right? So this times this is going to equal just v, so we're going to have like a v prime plus a v. Nice and linear. And this should then equal y cubed t. Well, again, y is v to the negative 1/2, right? Well, what's v to the negative 1/2 cubed? It's v to the negative 3/2, right? So if I multiply through by v to the 3/2, that's going to go away. I'm going to have a nice linear equation in v. Now, when we did the change of variables symbolically, we worked it out to the point where you would discover that this term goes away if you let v equal, or if you do a y to the m with m equal 1 minus n, where n is the power of y. Okay?
Will this work if that would like be a 3y squared?
The 3y squared here?
To the left.
No, it wouldn't be linear. It wouldn't be nearly linear. It wouldn't be a Bernoulli equation. A Bernoulli equation is linear on this side, but it has a power of y over here, and then some function of t. Okay? And you can look at your book and see what they say the form is. Something like y prime plus p of ty, just like your linear equation, right? Equals y to the m times q of t. I think that's the form they use. So, we'd say that. I think the form they probably give you is this okay? And this will become V prime plus P of TV equals Q of T if V equals 1 minus N. That's what the whole change of variable thing tells you. And if you had a y squared here, it would not be, this side wouldn't be linear. You'd have no hope of making it linear.
Alright, so.
V isn't 1 minus N though, is it?
Oh, I'm sorry.
It looks, and I wasn't really trying to recreate it there, but it kind of looks like this, in the sense, you got a bunch of
Y to
scattered
1 minus
dots
N.
running in another direction,
Okay.
right? Okay.
Okay.
So the first question that this golfer was asking, if the speed of the club goes up, will the
And
distance
again,
of travel increase?
I could well ask you work through the change of variable that proves this. The example shows that it works and gives you some insight into why the general derivation might work. But you see how nicely it comes out. So this is just becomes now you're going to have a constant here, right?
Here's what we're looking for. Look at page 182.
And
We're the ones we're going to concern ourselves with. Okay?
that constant really means that your P changes just by a constant multiple, right? So I could say
In other words,
plus a constant times P to the T, and the constant is just related to the value of N in a way that is fairly easy to see. Okay?
linear,
Okay, anyhow, V prime,
positive, linear association.
and then we multiply by negative 1/2 V to the negative 3/2. It's going to give us minus 6
Right? Okay?
V
You want to connect it back out to 1 and 2.
equals T.
Which means the line we're going to put through the box is going to have a positive slope.
Okay? So now your integrating factor.
It's gonna have a positive slope. The next graph, equation 2.4b, is a negative linear association, meaning as the input goes up, the output
And so on.
will be driven
Okay?
down, right? It would mean that if you draw a line through that, the line's gonna have a negative slope, okay? The third
Then you
graph,
substitute
the fourth, and the fifth, that shows you 5 graphs there.
y equals V to the negative.
182, you can see this. For our purposes, here,
Wrote it down
all we're
backwards.
really care about, those 3 graphs aren't linear, that's what we're gonna worry about. Be aware that when we say something's not linear, that doesn't mean nothing is happening. It just means that whatever the heck's going on, it's not linear. Okay? Graph number 3 has a distinct shape.
And you solve that for y if possible.
So there is an association.
Otherwise, your solution's implicit. You have an equation whose solution is your desired function. Maybe you can solve it for y, maybe you can't. Okay?
So why does it work just to substitute something else for your variable? Seems,
Well, it changes the form of the equation to where it's linear.
yeah,
This equation's totally equivalent to this equation.
seems like cheating.
Hey, analysis is all about cheating. Analysis is just a bag of tricks that you use to torture your equations into submission. So we've tortured this one, right? Actually, all we didn't really have to torture. We just threatened it a little bit and it came around. Okay? Sometimes you got to get really mean. Okay? Yeah. Just try to solve the Schrodinger equation for anything more complicated than a hydrogen atom. We'd solve it for the hydrogen atom. You probably already know enough differential equations to do that.
You know what X cubed looks like, don't you?
We'd solve the particle in a box. Any first-year calculus student can do that.
It has a quadratic.
But we haven't done that. We probably will. I would really like to be able to get your physics class so we can
Let's see. Now,
do the Schrodinger equation for a hydrogen atom. And we will probably do the particle in a box. It's just a wave equation, where your wave has a slightly different meaning than a mechanical wave. Probability, amplitude wave. Okay? It'll help you understand the structure of atoms. Any fool that decides they want to go into chemical engineering should know it. I think one of the class has expressed an interest in chemical engineering. Okay? And that's not why I'm doing it. It's just, it comes right out of the wave equation. It's something I've always wanted to be able to do, but I've been kind of leaving off most of the quantum mechanics from the course. Because once we get to RLC circuits and learn to interpret those, people are exhausted and they're not willing to even think about the quantum mechanics. Okay? Don't like to do that. I don't like to suppress relativity either, but I end up having to. Okay, well anyhow, that's the physics class. This is a Bernoulli equation. Now you know how to solve it. And it's relatively straightforward. I mean, there's nothing real complicated about this. And if you just remember that m is 1 minus n, to give you this, you can solve the equation. As I said, I also want you to be able to go through the derivation and see why m equals 1 minus n. No matter what the power is here, we'll change the equation to a linear equation. Okay?